In this video, we'll look at optimization with derivatives. The problem is as follows. A rectangular box is to be made with a flat piece of cardboard measuring 80 centimeters by 20 centimeters. Find the measurement of the box with the largest volume. Well, first we have to write down an equation for the volume. It might help to draw a sketch though, you don't have to, but if you want to see what we're doing here, where these numbers come from, we have a box that's 80 by 20, not to scale because the 20 looks very close to the 80. And then we want to cut off the corners. We did problems like this in grade 11 too. And when I say cut them, like not cut them completely, but cut them at the same length so that you can fold this up. It might be easier if you take a physical thing and actually cut through here, and fold this up. So fold this. So these corners come out, but then we fold up these sides. And so we're left with a box of some height x and some length and width. And so what am I going to write for the equation? Well, volume of a box is length times width times height. But we can say more. We can say if this is 80 and we're cutting x from here and we're cutting x from here, the length of the folded up box will be 80 take away 2 x's. Here, look at this one. Same thing. The x's are all the same. This is a length of 20, but we're going to cut down x this way and x this way, so the length of this side, or the width, is 20 minus 2 x's. And the height's just going to be x. So we get length of 80 take away 2 x's times width of 20 take away 2 x's times the height of x. Okay, well before we take the derivative, we got to do some foiling here, or distributive law. So rainbow this, I get 1600. Please watch a video of expanding using FOIL if you don't know what I'm doing here. 80 times 20 is 1600. 80 times negative 2x is 160x. Negative 2x times 20 is negative 40x. And negative 2x times negative 2x is 4x squared. All still times x. And I'm going to share this x with everything. And I'm also going to write it in descending order as polynomials should be written. So I'm going to get 4x cubed. I'm just doing this one first. And then, oh, I probably should have put those together. I'll do that on the next step. Minus 160x squared minus 40x squared. And then plus 1600x. Let's combine those like terms. I've got an equation for volume now, which is 4x cubed minus 200x squared plus 1600x. Well, how do we proceed? We're trying to find the largest volume. We're trying to maximize volume, so we take the derivative. What's the derivative of this? 12x squared. And please watch a video on taking derivatives of polynomials to understand what I'm doing here. Minus 400x plus 1600. We can't factor that. We could jump right to quadratic formula, though we actually could common factor it. What goes into all the numbers 12, 400, and 1600? A 4. That'll just make our math a little bit faster, but not much. So you didn't have to common factor. You could have just jumped right to quadratic formula, but I'm common factoring because I think it'll save me time. And now for quadratic formula, in class the other day I noticed I make mistakes more if I don't list my ABC. The A is 3, the B is negative 100, and C is 400. And I'm going to solve this. Oh, I should say, I'm going to set this whole thing equal to 0. I better state that. So I'll put this in a box, Bergman. Those are my coefficients. And then I'm saying work continues here. 0 equals 4. Why am I trying to solve for 0? Because I'm looking for critical points, and that's where f prime at x, or in this case v prime, equals 0. And now I'll do that using quadratic formula. I'll come up here to do that. X equals negative b plus or minus the square root. There's a song to the tune of Pop Goes the Weasel to remember quadratic formula if that helps you. So I get x equals negative b, that's negative 100, which is positive 100. Plus or minus the square root of b squared, that's negative 100 squared, minus 4 times a times c. Let's squeeze it in there, all over 2 times a. x equals 100 plus or minus the square root of 100 squared is 10,000. What's 10,000 minus 4 times 3 times 400? 5,200 all over 6. Make sure my fractions and my roots go the whole way. And so I'll solve both those pieces. I put a rounding dot because I know I'm going to round. 100 plus square root of 5,200 equals, divided by 6. I get approximately 28.685. And now the subtracting version, 100. There's videos on quadratic formula if you want to go over how to do that. Divided by 6. And I get approximately 4.648. Okay, well, right off the bat, we got to reject this one. And why are we rejecting it? I'll explain why. Go back to here, this width is 20 minus 2x, which means the most x could be is 10. In fact, x can't even be 10. If x were 10, this width would be 0, and you can't have a width of 0, or nothing less than it either. In other words, x has to be less than 10. And obviously x has to be greater than 0 as well, because you can't have a length or width that you'll see if you were to do the volume, the length and width would be fine, but the height is just x. And the height, of course, has to be at least 0, or you would get 0 times the whole thing. Can't have a volume of 0. So we're somewhere between 0 and 10, which means reject this one. We're just using this one. And normally we would check the endpoints, but we're just going to check x equals 4.648. Why don't we check the endpoints? Because the endpoints, again, are 0 and 10. If you sub in 0 into this volume equation, what you would get, of course, is 0. And we don't want a volume of 0. If you sub in 10, just looking at it factored form here, again, you would get a volume of 0. So we just want to check this one. That's going to be our volume. It's going to be our max. So let's find the volume at 4.648. We can use either equation, and now just looking at it, I could use this equation. This one probably will go faster. If I sub into 80 minus 2 times 4.648, now I'm thinking maybe not. Well, it's my choice, I'm going with it. And so I have 80 minus 4.648 times 20 minus 20 minus 2 times 4.648, all times 4.648, which equals, let's see what we get. I'm tempted to do all that at once just because I feel like I'm going to have rounding errors if I keep rounding. So 80 minus 2 times 4.4648 equals times, but now I'm going to need brackets, 20 minus 2 times 4.648 brackets times 4.648 gives me 3,535.5, I can put that flat so you can see it, 590. I had to round to the nearest 3 decimals because that's usually what I do. And it's in centimeters, but it actually doesn't ask for the volume. So technically I didn't even have to calculate that, but there's my max volume. What are my max measurements? Well, the height is easy. The height is just x, which is 4.648. What's the length? The length is just 80 take away 2 times 4.648, which is, I'm not sure, but we'll find out. 80 minus 2 times 4.648, you get 70.704. And the width, what's the width? The width was 20 minus 2 times x, so 20 minus 2 times 4.648. 20 minus 2, I gotta show my work here. And then write the answer, which is 10.704. It's a word problem, so I should put a word answer. Question, find the measurements of the box with the largest volume. The measurements are length of 70.74 centimeters, width of 10.704 centimeters and height of, can squeeze it in here, 4.684 centimeters. And we've done it. We found the largest volume, and we calculated which measurements gave that by making a volume equation, taking its derivative, setting it equal to 0, and finding the critical point by using quadratic formula. Note we had to reject one because it was too big for our constraints.